In this section, we are going to begin talking about a concept known as dynamic programming. Dynamic programming is mainly an optimization over plain recursion. So wherever we see a recursive solution, meaning that we have repeated calls for some input, we can typically optimize that recursive solution by using dynamic programming. Now I'm not going to spend too much time on dynamic programming, but it is a concept that I wanted you to be familiar with. So to start off, let's do a simple problem that we already know, which is the Fibonacci sequence. So we did this in the recursive section, but there is a dynamic programming solution to this as well. So we will create our function and we'll pass in an I32 and return an I32. So we will create a couple of variables called A, B, and C. So we'll say let mute A, let B equals 1. It helps if I assign 0 to A. And then we will say let mute C, and then it's going to be of type I32. So here we don't have to do any of our checks that we did in the recursive solution. We can do a simple for loop, and we don't care about where in the for loop we're at, so we'll just designate it with the underscore, and then we'll say from 2 and then include all the way up to the value parameter that we're passing in. That way we also include that value, and then we will simply say C equals A plus B, A is equal to B, and then B is equal to C. And now we want to return B. So probably looks a lot different than our recursive solution, but we can test this out to make sure that it works properly. So we'll implement a quick test case on it. Mod test, use super, bring everything into scope, and we will say we have a test case where we want to test our Fibonacci out. So in here we will say assert equals, and we will say Fibonacci of 9, and the result should be 34. So if we run our test, try adding, that would help, for n. Now if we run our test, we see that our test passed successfully. So again, this was a very simple solution, and I wanted you to get familiar with what dynamic programming is. And again, dynamic programming is used as an optimization over plain recursion. So wherever we see a recursive solution, we can typically optimize it using dynamic programming. And what we did here is we took our recursive Fibonacci solution and turned it into a dynamic programming solution, and we see that it works just fine. So now that we have a general understanding of what dynamic programming is, we will look at a couple of additional problems to really solidify our learning on dynamic programming, and we will start with looking at what the longest common subsequence is in the next lecture.